Ever wonder how AI can actually understand the world around it? Like not just recognize a cat in a photo, but explain why it's a cat or spot a tricky lie in a chart. That's the cutting-edge work happening in vision language models right now, and it's more exciting than ever. Let's break down what's new, why it matters, and where this tech is headed. Here's the thing. Even the best AI models today still struggle with complex visual reasoning. Ask them, why is this graph misleading? Or what's the main idea of this chart? And they'll often fumble. It's like giving a robot a textbook and asking it to write an essay. It can memorize facts but not understand them. But researchers are pushing harder than ever to close that gap. The secret: smarter training. One game changer is knowledge distillation, a technique where a huge, powerful AI model, think of it as a genius teacher, teaches a smaller, faster model, the student, how to think. It's not just about copying answers. The student learns the logic behind them. For example, models like Distillation and MoveKD show that even tiny AI systems can handle complex tasks without losing speed. It's like teaching a toddler to solve puzzles by watching a master puzzler, except the toddler ends up being super smart. Then there's sparse mixture of experts, a fancy way of saying, let the right specialist handle each task. Imagine a team where one expert cracks math problems, another deciphers art, and another translates languages. The model only calls on the right expert for each question, making it super efficient. Papers like MPLUG.CAL and Eagle are using this to tackle documents and tricky visuals better than ever. But here's the real kicker. The data these models learn from is getting way more detailed. Projects like ChartQA and Sujet Finance QA Vision 100K are building massive libraries of visual questions. Think of them as AI's ultimate puzzle books. The more complex the puzzle, the smarter the model gets. Now let's talk about the practical side. The best AI models today, like GPT-4V or Claude-3.5, are massive. They're like supercomputers in a box, trained on billions of examples. But here's the problem. They're too big to run on your phone, a smart camera, or even a hospital's diagnostic tool. They're powerful but not practical. So how do we make them useful? Enter distillation, a technique where we take a giant, super smart AI, the teacher, and teach a smaller, faster AI, the student, to mimic its answers. It's like giving a student a cheat sheet from the teacher's notes. But here's the twist. The teacher and student often speak completely different languages. Think of it like this. Imagine trying to teach a French chef to cook a Spanish dish using a recipe written in English. The ingredients and steps are there, but the vocabulary is all wrong. Traditional distillation methods only work if the teacher and student use the exact same token system, the way they break down images and text into data. If they're mismatched, the student can't learn effectively. That's where GenRecal comes in. It's like a universal translator for AI. The key innovation: a component called the recalibrator. Here's how it works. When a large VLM, the teacher, processes an image and text, it generates a set of internal features, like a sketch of its thoughts. The recalibrator reformats these features into a shared language that the smaller VLM, the student, can understand no matter what token system they use. It's like taking that French recipe and translating it into Spanish, so the chef in Mexico can follow it perfectly. Let's break it down. The teacher model looks at a photo of a cat and a question like, what color is the cat? It processes the image, extracts features, and generates an answer. The recalibrator takes those features and recalibrates them, aligning them with the student model's internal system. Now, even if the student uses a different set of words to describe colors, it can still learn from the teacher's knowledge. And the results? GenRecal blows past older methods. In tests, smaller VLMs trained with GenRecal outperformed both open-source and closed-source models, proving that size isn't everything. So what's the big takeaway? These models are getting closer to reasoning and context, but they're not there yet. They still struggle with ambiguity, like figuring out what a blurry photo really shows. The next step: teaching AI not just to see, but to think about what they see. The future of AI isn't just about bigger models, it's about smarter, more efficient ones. And with techniques like knowledge distillation, sparse experts, and tools like GenRecal, we're already seeing AI shrink without sacrificing power. Imagine a world where your phone's camera can explain a chart, or a smart fridge can read labels and suggest recipes. It's not science fiction anymore, it's the next frontier. What do you think? Are we close to AI that truly understands the world? Let me know in the comments, because the future of vision language models is still being written. Thanks for watching and stay curious.